Hi students, complex analysis unit ಅಲ್ಲಿ. So still now we studied the definition and some of the basic problems, basic definitions, limit of the function, continuity of a function, differentiability of a function. Then we came to the analytic functions. In the analytic functions we studied the definition, CR equations, necessary and sufficient condition proofs, next polar form of a Cauchy-Riemann equations, orthogonal systems, harmonic functions, then Laplace equations and harmonic conjugates. So up to there we completed the portions. Next we will start construction of analytic function method number 1 and construction of analytic functions method number 2. So let's will see in this video construction of analytic function method number 1. You can see here construction of analytic function. In here, suppose u is a harmonic function, then find v the harmonic conjugate of u. Find v the harmonic conjugate of u. Okay, so this implies f of z is equal to u plus iv forms an analytic function. ಇಲ್ಲಿ u ಕೊಡ್ತಾರೆ, u ಫಂಕ್ಷನ್ ಕೊಡ್ತಾರೆ. ಸೊ v ಅನ್ನೋ ಫಂಕ್ಷನನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಸೊ ಇಫ್ ದೇ ಆರ್ ಗಿವಿಂಗ್ ದ u is a harmonic function, then for u you are going to find out as a v, then we will call it as a harmonic conjugate ಅಂತ. ಓಕೆನಾ? ಸೊ ಇದಕ್ಕೆ ನಾವು ನಮ್ಗೆ ಎರಡು ಮೆಥಡ್ಸ್ ಇದೆ ಅನಲಿಟಿಕ್ ಫಂಕ್ಷನ್ಸ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋಕ್ಕೆ. ಸೊ ದಟ್ ಈಸ್ ಮೆಥಡ್ ನಂಬರ್ 1. If we see in the method number 1, so here there is an example. With the help of example I am going to explain the method number 1. So this one we already studied in the our previous classes. So let me to explain this method number 1 problem. Prove that u is equal to x cube minus 3xy square is harmonic. You can see here u is a harmonic, so they are giving like that here. And the analytic function, and find the analytic function whose real part is given. So that only u they give, we have to find out. So let's will see how to find out this v. So because we have to construct a analytic function ಅನ್ನು ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಮಾಡಬೇಕಂದ್ರೆ u ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಾಗಬೇಕು, v ವ್ಯಾಲ್ಯೂ we should know, then only it is possible to find out the analytic function, that is f of z. So u value is ready, then v value we have to find out. To find out v value, let me to follow the method number 1, construction of analytic function. Here by data u is equal to x cube minus 3xy square. So this one, once you differentiate with respect to x and with respect to y, then again differentiate, double differentiate, okay, double differentiate, and therefore you can make it dou square u by dou x square plus dou square u by dou y square is equal to, will get as a 0. So when we will say the function is a harmonic, means the harmonic function should satisfy the Laplace equation. This is the Laplace equation. If the equation is satisfies the Laplace equation, then we will call it as a harmonic function. If u is a harmonic function, then we can find out the v. So if u is not a harmonic function, then it is not possible to find out the harmonic conjugate, that is nothing but v. So now as we proved here, u is a harmonic function. So next we'll start to find out the v function. Let v of x comma y be the harmonic function of u of x comma y, then we have the formula dv is equal to dou v by dou x dx plus dou v by dou y dy. So this one I am going to replacing this equation by, because of CR equation, I am going to changing, that is dou v by dou x I am going to replacing as a dou u by dou y. Now in here dou u by dou y, we already did the partial differentiation once, so that value is substitute here, and dou u by dou x, that value also substitute here. Next here integrate, okay, integrate both sides, so that side dv it will be there, so that it will become v is equal to m of dx plus integration of entire term, okay, so that is dy. Here whatever the terms it will be there in this particular place, whatever the function it will be there, x function it will come, is that it will become 0. So here m value, that is 6xy dx plus integration of minus 3y square dy. You have to follow the previous step to understand this one. So v is equal to integration of this 3x square y minus y cube plus c, integration constant. So u value they gave, v value we found here. So then f of z, that is analytic function, is equal to u plus iv. So u value they gave, v value we found out. So this one further simplification you can do it, we will get the analytic function. So this is method number 1, we already studied in our previous classes, that is harmonic conjugates. Okay, next method number 2, let us to start. This method number 2, it's very important for examination point of view. So this one we are going to call it as a Milne-Thomson method. We have another method of construction, that is analytic function construction. Okay, analytic function construction, we will call it as a Milne-Thomson method. So you can let us to follow the certain steps to get the formula Milne-Thomson method. Here you can just look at here, we have f of z is equal to u plus iv, and z is nothing but x plus iv. Here then x is equal to 1 by 2 z plus z bar. If you take it as a x is nothing but 1 by 2 z plus z bar. Similarly y is equal to 1 by 2i z minus z bar. Then what will happen, you can just have a look at here, f of z is equal to u of, this is x, you can see x I am going to replacing as this equation, and y I am going to replacing as this one, plus iv as it is, x I replaced and y also I replaced here. This one I am going to call it as equation number 1. Next, putting z is equal to z bar in equation number 1, we get in this particular place I am going to replacing z as a z bar. You can see here, if I substitute z as a z bar, means what will happen here, 2 time, okay, this is, look at here, z is a z bar, here I am going to replacing as a z, this it will become 2z, then 2 it will get cancelled, z is the left out. Then here if you replace z bar as a z, then what will happen, z minus z, it will become 0, so then it becomes 0, plus iv. Similarly here also same procedure I am applying, and I will get z comma 0. So this is f of z. Next, so this is same as the expression obtained from f of z is equal to u of x comma y plus iv x comma y. Here what I am going to do, x I am replacing as a z, because in the previous case we got it as a, that is in the x place we got it as a z, and y place we got it as a 0. So that one I am going to apply here, x is replaced by z and y is replaced by 0. Please keep it in your mind, these two points. Next, since f of z is analytic, if it is analytic, then definitely it should be a differentiable, means it exists a differentiation, that is f dash of z is equal to dou u by dou x plus I dou v by dou x. Then here with the help of CR equation I am going to replacing this one because of CR equation. Because of CR equation, f dash of z is equal to dou u by dou x plus I dou u by dou y. Let I am going to considering here this one dou u by dou x is equal to pi 1 of x comma y and dou u by dou y is equal to pi 2 of x comma y. I'm considering this one dou u by dou x is nothing but pi 1 of x comma y and dou u by dou y is nothing but pi 2 of x comma y. So we are doing Milne-Thomson method to find out the formulas. Okay, then f dash of z is equal to, so this one what happened, phi 1 of x comma y here minus I of pi 2 x comma y. So this one it will become minus. This one will become minus because CR equation. So this is I pi 2 x comma y. Then as for this two step, that is x is replaced as a z and y is replaced as a 0. So that is f dash of z is equal to pi 1 of z comma 0 minus I pi 2 of z comma 0. On integrating both side we get the differentiation. It will become f of z is equal to integration of pi 1 of z comma 0 dz minus I integration of pi 2 z comma 0 dz plus integration constant. Okay, similarly if v is given means f of z it will become, that is psi 1 z comma 0 dz plus I integration psi 2 z comma 0 dz plus c, where psi 1 x comma y is equal to dou v by dou y, psi 2 x comma y is equal to dou v by dou x. These two formulas very important. Okay, so you can just have a look at here. If they will give u means they will give means we have to use the formula f of z is equal to integration of pi 1 z comma 0 dz minus it will come here. U means minus it will come here. Okay, minus I integration pi 2 z comma 0 dz plus c. Similarly here, okay, in the problems if they will give v is they are given and u we have to find out. At that situation we have to use the second formula. You can just have a look at here, that is f of z is equal to psi 1 z comma 0 dz plus I integration psi 2 z comma 0 dz plus c. Okay, the main difference between these two formulas are here minus it will come, here plus it will come. So please keep it in your mind. So don't confuse these two formulas. Now let us see the problems, very important problems for the examination point of view. So let's see one. Problems based on Milne-Thomson method. Now we'll see the problem number 1. You can see u they are given here. U they gave. Find the analytic function, that is f of z. U plus iv we have to find out. It means u is ready, v we don't know, we have to find out with the help of method number 1 or else method number 2. So method number 1, what will happen, if the given functions, okay, it will become complicated, means the method number 1 it is not possible in the sense it will become complicated. So with the help of Milne-Thomson method we can find out very easily the conjugate of the given function. So that is v, we can find out very easily. Now you can see u they gave, v we have to find out. So definitely the first formula we have to use. What is the first formula? F of z is equal to integration of pi 1 z comma 0 dz plus I, that is sorry, not plus, it is a minus. First formula, it is a minus I integration pi 2 z comma 0 dz plus c. That formula we have to use if they will give as a u is nothing but minus. Please keep it in your mind. We have, so let us to see the solution. We have u of x comma y is equal to e to the power of x, okay, into x cos y minus y sin y. So we have to observe the variables correctly here. E to the power of x, that if we multiply here, x it will come, means the x functions, okay, x functions it will come 2 times here, and cos y function only 1 time it is there here. So minus again e to the power of x, if you multiply here, y functions it will come 2 times here. Here x functions it will come 2 times, y functions it will come 2 times, because we have to do the partial differentiations with respect to x and with respect to y while we are doing this. So very carefully should do. You can just observe here. This one you can follow for, this one you can follow for dou u by dou x. To find out the dou u by dou x, this one without substituting, okay, without substituting equation you can follow, you get a easy solution. So now pi 1 of x comma y is equal to dou u by dou x. With respect to x I am doing differentiation, is equal to, look at here, two functions, this one and here this entire task. Now here what I am going to do, first function I am keeping as it is, first function I am differentiating, that is e to the power of x is nothing but e to the power of x only. Second entire function I am keeping as it is, plus now first function I am keeping as it is, second function I am differentiating with respect to x. Where is there x here? Only in the first case, that is e to the power of x, x cos y. So here what will happen, only this second function we are doing differentiating, okay. So this one x it will become 1, then remaining it is left out cos y. So it's very clear, this one once you do it yourself in a rough book, then you will get to know this one. Next, similarly here pi 2 x comma y is equal to dou u by dou y. With respect to y I am doing now is equal to, so for this, okay, pi 2 of x comma y, so I am going to follow this one, that is dou u by dou y, okay. But from here itself we can do, but to avoid the confusions, so I substituted this e to the power of x in the brackets, then I am doing the differentiating, okay. It will become easy. Now dou u by dou x is equal to, dou u by dou y is equal to, look at here, in here with respect to what I am doing, y. If I am doing y, so e to the power of x I am keeping as it is, x also I am keeping as it is, because y I am following, cos y is nothing but minus sin y, minus as it is e to the power of x I am keeping as it is. Here with respect to y we are doing the differentiating, we have y in the two places, ನಮಗೆ ಎರಡು ಕಡೆ y ಇದೆ, ಅದಕ್ಕೆ ಈಗ y ಅನ್ನು ಹಂಗೆ ಇಟ್ಕೊಂಡು sin y ಅನ್ನು ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡಿದ್ರೆ cos y ಬರುತ್ತೆ, ಪ್ಲಸ್ sin y ಅನ್ನು ಹಂಗೆ ಇಟ್ಕೊಂಡು y ಅನ್ನು ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡಿದ್ರೆ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು y ಮಾಡಿದ್ರೆ 1 ಆಗುತ್ತೆ. ಸೊ ದೆನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ದಿಸ್ ಮೈನಸ್ x e to the power of x sin y minus e to the power of x y cos y minus e to the power of x sin y. Just simplification, e to the power of x you can eliminate here, the remaining whatever the terms are left out, that you write as it is. Okay, see pi 1 is ready, pi 2 it is ready. Now by Milne-Thomson method, f of z is equal to integration, because u they gave, we have to use the minus sign, pi 1 of z comma 0 dz minus I integration pi to z comma 0 dz plus c. Here whatever the solutions we got it, that is pi 1 of x comma y, it is not a pi 1 of z comma 0. So what I'm going to do here, look at here, wherever the x is there I'm going to substitute as a z, because pi 1 x value is z, y value is 0. So this is e to the power of z, and here x is nothing but z, cos y is nothing but 0, cos 0 is nothing but 1, then it will become z into 1 minus y, this term it will become 0, this term it will become 0 plus in here e to the power of x is nothing but z, cos y is nothing but 1, then dz you write on as it is, minus I integration e to the power of, next here in the pi to x comma y, here I am going to replacing z, x as a z, y as a 0, it is e to the power of z, here e to the power of x is nothing but e to the power of z, minus as it is x is nothing but z, sin y is nothing but sin 0, it will become 0, minus y it is there, so this entire term it will become 0, sin y 0, next dz plus c integration e to the power of z, okay, into z, this one plus this e to the power of z dz minus I integration of e to the power of z, this entire task it becomes 0, dz plus c, this is equal to integration of e to the power of z, I am eliminating here, remaining it is left out z plus 1 dz plus integration constant. Now here we have, in two cases we have the z, with respect to dz we have to integrate, means integration by parts we have to use here. So that is this this will become the second function and this will become the first function, we know that. So first function I am keeping as it is, second function I am integrating, minus integration of differentiation of first function, that is 1, and whatever the integration we did here, that one again we are going to write in here. So that is e to the power of z, this is dz plus integration constant. Now this you multiply inside, that is e to the power of z into z plus 1 into e to the power of z, e to the power of z, minus integration of e to the power of z is nothing but e to the power of z only, plus for this integration constant, that integration constant, and this c and one more c, it will become c1, then e to the power of z plus e to the power of z minus e to the power of z, it will get cancelled, e to the power of z is equal to e to the power of z e to the power of z into z plus c1. So this is the analytic function they gave you, and we have to find out the analytic function with the help of Milne-Thomson method. It's very clear about this problem. So next we'll see one more problem based on Milne-Thomson method. In here you can see again, if u they are giving, u means a negative, that is negative whatever the formula I was saying, the first formula we have to use, u is equal to sin 2x divided by cos hyperbolic 2y plus cos 2x. Find the corresponding analytic function f of z is equal to u plus iv. U they gave here, pi 1 and pi 2 we have to find out as it is, pi 1 and pi 2 we have to find out. Here you can see pi 1 of x comma y is equal to dou u by dou x. Here you can see numerator and denominator it is there. X, if you observe with respect to x, we are doing the differentiation. So the x is present in numerator as well as in the denominator. So we have to use the quotient rule here. So here, so denominator, so this one I am keeping as it is. Second one, if you do the differentiation, it will become sin 2x, it will become cos 2x into 2 by chain rule, and the minus second one as it is I am keeping, and denominator part I am doing the differentiation with respect to x. Okay, in here denominator we have two functions. Okay, in first function x is not there, only in the second function it is there, the x. So that if you differentiate, it will become minus 2 sin 2x, cos 2x, it will become minus 2 sin 2x.